All right, let's dive into NumPy, the absolute powerhouse behind data science in Python. Seriously, if you've ever wondered how Python crunches through millions of data points like it's nothing, well, you're in exactly the right place. Let's get into it.
So, picture this. You've got a data set with a million rows, or maybe 10 million, and you need to do the exact same calculation on every single one of them. How do you pull that off without waiting forever? How do you do it fast? This, right here, is the challenge that data science lives and breathes every single day.
And that challenge leads us to what you could call the data scientist's dilemma. Look, we all love Python. It's easy to read, it's super versatile, and the community is massive. But its standard out-of-the-box tools just weren't built for the kind of high-speed number crunching that modern data analysis is all about.
I mean, just think about Python's go-to for storing a bunch of stuff, the list. Lists are awesome because they're so flexible, right? You can mix numbers, text, whatever you want. But that flexibility, it comes with a huge price tag. Every time you do math, the list has to stop and check the type of every single item. For huge operations, that creates a massive bottleneck. It's just not built for speed.
So, if Python's lists are the problem, then what's the solution? Well, this is where the hero of our story makes its entrance: NumPy. It was literally created to solve this one big problem, giving us an incredibly powerful and efficient foundation for doing math in Python.
So, what is NumPy? Well, the name kind of gives it away. It stands for Numerical Python, and its job is right there in the name. It is the fundamental package for scientific computing in Python. It's not just some random library. It is the absolute bedrock of the entire data science ecosystem. And it does all this by giving us a totally new and powerful way to handle our numbers.
And here it is, its secret weapon, the n-dimensional array, or as you'll see it, the ND array. Just think of it like a super organized grid that can have any number of dimensions. A simple line of numbers, a 2D table like a spreadsheet, or even a 3D cube of data. This whole structure is engineered from the ground up for one thing and one thing only: processing numbers at lightning speed.
Okay, so I keep saying speed, fast, lightning speed. Let's actually dig into why NumPy is so much faster and more efficient than a plain old Python list.
This slide really says it all. It's all about a trade-off. Python lists are super flexible. You can toss any kind of data in there. But NumPy arrays, they're strict. Every single element has to be the same data type, like an integer or a float. And you know what? That constraint is its superpower. By forcing everything to be the same, NumPy can pack all the data together in one tight, continuous block of memory. That means the computer can just blast through the whole thing at once. It's insanely fast and way more memory efficient.
And this is no accident. This isn't just a happy coincidence. NumPy arrays were purpose-built, literally engineered from the ground up. Every single design choice was made to squeeze out the absolute maximum speed and efficiency for working with numbers.
I love this analogy. It's just perfect. A Python list is like that general-purpose toolbox you have at home. You know, it's got a hammer, some screwdrivers. It can do a lot of different jobs pretty well. But a NumPy array? That's a specialized power tool. It's designed to do one job, crunching numbers, and it does it with a level of speed and precision the toolbox can't even dream of. Okay, so we've established it's fast, but what does that speed actually let us do? This is where we get to the really cool part, the practical stuff, the data superpowers that NumPy just hands to you.
Superpower number one, massive mathematical operations. So imagine you've got an array with a million prices, and you need to add sales tax to every single one. In regular Python, you'd have to write a loop to go through them one by one. Slow, boring. With NumPy, it's one command. You just say, hey, array, add this number, and poof, it happens, almost instantly across the entire dataset.
Next up, statistical analysis. You need to find the average of your data, the median, the standard deviation. Instead of you having to write out all the complicated functions, NumPy just has these built right in, and they are highly optimized. It lets you turn a giant sea of numbers into actual, meaningful insights with just a single line of code. It's awesome.
And finally, for the really advanced stuff, you've got linear algebra. Now, don't let the name scare you off. This is basically the language of machine learning and modern AI. All those complex matrix operations that power AI models, NumPy handles them beautifully, making it an absolutely essential tool if you're serious about data science.
So now, let's just zoom out for a second. We've seen what NumPy can do on its own, which is impressive for sure. But its true importance, that becomes crystal clear when you see where it fits in the whole data science universe.
And honestly, if you take one thing away from this, let it be this. NumPy isn't just another library you can choose to use or not. If you're doing data science in Python, you'll quickly realize that almost every other tool you touch is built directly on top of this one single foundation.
I mean, just look at this stack. At the very bottom, holding everything up, you've got NumPy. Then, built on top of that, you have pandas for analyzing data, matplotlib for making charts, and even scikit-learn for machine learning. All of them, every single one, depends on NumPy's arrays to work. So learning NumPy doesn't just teach you one library, it gives you the key to unlock the entire Python data science ecosystem.
So the takeaway here is pretty simple. NumPy brings the speed and the power you need to work with data at a serious scale. It's the engine that drives pretty much everything else. So the only real question left is, your data's waiting. Are you ready to unlock its speed?